Hey 11s, today we're going through exercise 2F on families of straight lines on page 59 of your textbook. So this one is actually a little bit interesting, a lot more application style, and actually just looking at, well, how do these lines relate to each other? Because when we're looking at the equations of lines, we're actually looking at families and how they're actually related. So if I've got this over here, this is my Desmos graphing calculator, just to show how those variables are related. I've got y equals mx plus c in the top. That's what this equation on the right hand is here. You can see it's a linear equation, and on the left hand side, I've got m equals to 1 and c equals to 1 over here. Now the question is, what happens as I change these values? Now m, remember, is my gradient. If I make my gradient more positive, it means my gradient, well, it becomes steeper, my line becomes steeper. As I bring it back down, it gets to a point where it goes down to 0, where it becomes completely flat. And if I keep going negative, it'll go back down. Also steep, but in the opposite direction. So looking at, well, what happens if I have the same equation where those values are exactly the same except one thing is different? So let's bring that back up to 1, our gradient there, and think what happens if I change my c value. Remember, c is a constant. That's what actually c stands for. That's what c stands for, despite it being the y-intercept. And what happens if I change that? So it becomes more positive, the whole graph lifts up, and as it becomes more negative, the graph goes down. So you can see what happens when my gradient and my c-intercept changes. We end up with a, well, very odd family. So what happens if we can separate those equations and look at it as specific families? So over here, I've got find the value of m if the line y equals mx plus 2 passes through the point 3 and 11. So what I've done is just highlighted what we want to know and what we do know. So let's go ahead and understand this from the perspective of different families. I've got y equals mx plus 2, remembering that with y equals mx plus 2, I know that my y-intercept is going to be 2. So let's say that's 2. My graph is either going to look like any, oops, I missed that. It's going to look like any one of these lines. Doesn't matter which one, as long as it passes to that point. Okay? So that's what y equals mx plus 2 is going to look like. Now, depending on what point we're looking at, in this case 311, depending on what point we're looking at, we're going to end up with a very specific line, because only one of these lines, unless it is that point 02, only one of these lines passes through the point 311, which might be up here. Okay, so we're looking for that very one specific line. All we have to do is actually solve it as we would do with a normal equation. We know that's x, we know that's y. So I'm going to rewrite y equals to mx plus c, well, plus 2, sorry, that's what the question is, and replace our values with what we already have. In this case, x is 3 and y is 11. So I get 11 equals to m. It's an 11, let's fix that up. 11 equals to 3m plus 2. I'm going to go ahead and solve for m because we're finding the value of m. Take away 2 on both sides, get 9 equals to 3m, and therefore m equals to 3. And so I know my gradient is 3, which actually does match our picture right here, where our gradient is generally quite positive, and we end up with 3. Okay, so the actual equation, now it's not part of the question, but the actual equation would be y equals to 3x plus 2. If I was to substitute this point over here, it would indeed give us that, give us a true statement, and also it does go in line with us having that positive 2 y-intercept. Now this question over here is a little bit interesting. What I've done is I've essentially gotten one of the textbook questions, I think this is question 6, and just changed, question 7, and changed the values around a little bit. Okay, so a family of lines have equations of the form x over a, take away y over 17 equals 7, where a is a non-zero number. And we're asked to find the x-intercept in terms of a. So this is a very specific question. It's a very niche question, but it's a good idea that we are able to break this down. Once again, if I'm talking too quickly, please feel free to pause the video. So I know that I've got x over a. I'm going to go ahead and write that. X over a minus y over 17 equals to 7. And we need to find the x-intercept. As per usual, when we're finding our x-intercept, we let our y equal to 0. I'm going to go ahead and do that and end up with, let's use a different color. There we go. X over a, take away 0 over 17 equals 7. Or in other words, x over a equals to 7. Multiply both sides by a, and I get x equals to 7a. Now it says find the x-intercept. That is not actually the x-intercept. That is an equation or a value. X-intercept, I'm going to write therefore. That's what those three dots mean, by the way. Therefore, x not x, sorry. Therefore, the point we have is x int equals to 7a, 0. Okay, so that's part A. Now we need to find part B. Find the gradient of the line in terms of A. So, same idea, but we're looking for the gradient. Once again, what I'm going to do is I'm going to actually go ahead and try and change it into a gradient intercept form, remembering that we have y equals to mx plus c as our gradient form. Gradient intercept, sorry. So right now, I've actually got x over a, take away y over 17 equals to 7. I'm going to go ahead and rearrange that. So I'm going to try and get, well, x over a on the other side. So take away that on both sides. Y over 12 equals to negative x over a plus 7. Just because this is a little bit more of a complex equation, I'm going to go ahead and write my working out on each side over here in different color. Next, I'm going to go ahead and multiply both sides by 12. So multiply by 12, and end up with negative y equals to negative 12x over a. Plus, now 7 times 12 gives me 84. Okay. Now I'm going to multiply both sides by negative 1 in order to get y by itself. Multiply negative 1, and I end up with y equals to positive 12x over a plus, so not plus, minus 84. Now remember that a is a constant value. So if we go back up over here, it says that a is a non-zero number. Okay, so remember it is a specific value. It's not a variable, it's a specific value in this case. So I've got y equals 12x over a. I can actually rewrite that as y equals to 12 over a x take away 84. That does also stand true because that is one value. I can now say, remembering that we have y equals mx plus c, that this is my m and this is my c. And therefore, m equals to 12 over a. And that is my final answer. Hopefully that makes a bit of sense. A lot of this exercise is just practicing what we already know. When we come back to school, we'll go ahead and do these questions. Best of luck.